So here we are again with the people online watching me hook this thing up. There we are. Sorry to the online people. It looks like I'm going to have to start the tape before I connect this thing, so you'll just have a few minutes of watching me ding around. I didn't ask for that. That's the way Microsoft is. They give you all kinds of stuff you don't ask for. Why is that? I wonder if that helps us. Quick, here to make this full page. Yeah. Now we're cooking. Now we're cooking. I'll learn how to operate this eventually by the time the semester ends. Okay. Any questions? I didn't get very many. I told my wife when I got home, I've been sending so many emails. I'll bet I'm going to get 40 emails asking questions about the homework. And nobody did. Well, I think a couple of people did. So the rest of you got it all done, or you're still working on it? After class today, I have to get dressed in that robe to go to convocation, so I won't be able to spend as much time helping you. But after chapel is over, I'm going to come back in here and be here to help people as long as you need help. Yes?
Where would you like us to put
your homework?
Yeah.
Just lay it on this on the corner of this table. Okay. Just bring it up here and lay it on the corner of this table. Or you know what? Since when you're on your way out, just put it on that table at the back. I'll pick it up back there at the back.
Okay.
Does that work for everybody? And I'll take them home and grade them and post your grades on Canvas.
Can you help me? I struggled with the part one. I struggled with it, and I'd like some extra help if you wouldn't mind.
With the first problem from the homework?
From section
1.1.
I struggled with half the problems.
Okay, so that's why. Are you available after chapel?
I am.
Then I'll come back in this room and I'll just help whoever's here. We'll just work on this stuff till it makes sense to you. And if it didn't make sense and you couldn't get it done, then don't worry about it. Come back and I'll help you. We'll work through it and you can turn it in on Friday and I won't count it as late. Okay? All right, any other questions? We're in good shape. We're starting about the same time we did yesterday. It's going to get better. I'm going to learn how to do this and get it down, but this is definitely the way to go, because it's going to only take us about 45 minutes to get through the material, I think. Problem number 2 on page 22. Water is sold in 1,000-gallon units. A unit of water costs $1.88. So I put down here for problem number 2, 1,000 gallons cost $1.88. Isn't that what they said? And 50.439 units were used. 50.439 units. And 1,000 gallon is what? 1 unit? Is that what they said? Is that what they said in the book? Oh, you don't have a book?
Nope.
Nobody's sitting next to you with a book? Nobody has a book. No wonder we're in trouble. Get those books. Oh, thank you. Thank you, thank you. Put that book in the middle and all three of those can look at one book. When you come to class, sit next to somebody who has a book so you can look at it and see what's, because otherwise you're not seeing how this stuff works. Now it says, find a reasonable estimate. A reasonable estimate, whatever that means. To the nearest $100. Oh, to the nearest $100. Okay, so now they're telling us how close to estimate for the water bill. Well, it's $1.88 for 1 unit. 50 units would multiply, right? But if they want me to estimate, I can't do that in my head. Well, I could, but you probably can't. So I probably couldn't either now. So let's just put a 2 up here, okay? And say $100. See what I did? I'm just rounding something off. And I know $100 is going to cover the water bill. Because it's really only $1.88. If you take 50 times that, it's what? 0.0049. It's really $94. But they didn't ask me to figure it exactly. They just said to the nearest $100. It's $100 to the nearest $100. Got it? Number 4. A student bought a towel for $8.99, soap for $2.39, toothpaste for $3.79, shampoo for $1.79, a pair of shorts for $8.79, and a hat for $9.99. I'm tempted to write all that down. But I'm going to keep reading. Find a reasonable estimate of the total purchase by rounding each quantity to the nearest dollar. Aha. So what's $8.99 rounded to the nearest dollar? 9.
Excuse me?
What's, where'd he go? What's, yeah?
In number 2, can you go back up to it? I didn't understand what you were saying. You were moving really fast. So it's only $100?
So what?
The answer was only $100?
Yep.
But they used 50 units of it.
And what's 50 units times $1.88? Got a calculator? Punch that number in, what do you get?
Okay. Thank you.
What'd you get? 94? But they didn't want me to say 94. They want to know approximately
Okay.
to the nearest $100. So
Thank
my
you.
answer is $100. Okay? Good. Number 4. Soap was $2.39, so what's down here for soap? 2. Toothpaste was $3.79, so what's down here for toothpaste?
4.
Shampoo was $1.79, so what's down here for shampoo?
2.
Pair of shorts is $8.79, so
9.
and a hat for $9.99.
10.
Find a reasonable estimate of the total purchase. The total purchase would be 11, 15, 17, 26, 36. Is that right? Okay? Everybody follow that? Let's move up and do another one. Number 6. A bag of grass covers 1.75 acres. One bag covers 1.75 acres. What's a reasonable estimate of the number of acres that can be covered with 158 1/2 bags? 158. Is that what it said?
Mm-hmm.
And 1/2 bags. Is it really making a difference with the lights off back there? Let me go turn them on and see what you think. See, I can't remember.
Yeah, it makes a difference.
Is it better with them off?
Yes.
Yes or no?
Yes.
If it doesn't matter, I'm going to leave them on because I can see better. But what's more important? One old guy seeing better, or a whole bunch of, or 30 people seeing better? 30 people seeing better. That's what's better. 158 bags of seed to the nearest 100 acres. Now see, to the nearest 100 acres. How many acres? If one bag does 1.75 acres, then 158 bags. Now, you've got to, when you're doing estimation, you've got some latitude. There's how you do it. Here's how I'm, in my mind, I'm thinking, okay, what I'm doing is estimation means I'm going to do mental arithmetic. So I put it in a way that I can handle it mentally, and I'm going, you know what? That would be like saying 150 bags or 160 bags and 2 acres. You follow me? Mm-hmm. And what's 160? Oh, let's just change it. I forget what this thing does. Isn't that so cool? 150 times 2.
50 instead of 60.
Because one bag won't do 2 acres, right? So I'm thinking I back down. So I've got a smaller number here. Since this number's going up, I'll bring this one down. You see what's going on in my head? So what's 2 times 150? 300. And I'm thinking that's my answer. Now, if the answer book said something different, okay, if this was a homework problem and you showed me this work you did, that you made this 2 and you made this 150 and you got 300 and the answer book said something different, I would count this as correct.
I got a question. Where'd you get your 2?
What?
Where'd you get the 2 in that? And just
1.75? I can't do 1.75 in my head, so I'm either going to go to 1 or 2.
okay.
So I can do it in my head.
And then you times it.
And I can take 2 times 150 in my head.
Gotcha.
So if the answer book said differently, I say, well, we're estimating, so my answer's as good as yours. Okay? So don't get stressed about it. Life's too short for that. Number 8. The highest batting average for a season belongs to Hugh Duffy. Well, good for you, Hugh Duffy, who played for Boston. He had 236. What do you have? Hits. Boy, someone hits you that many times, that has to hurt. And 539 at bats. They hit him with a bat? No, this is baseball. You go, I don't know anything about baseball. You don't have to. You don't have to know baseball to work the problem. Don't? No. What was Duffy's batting average? What's his batting average? I don't know. Does it tell you how to figure batting average anywhere in here? Ah, problem 7. What does problem 7 say about how you calculate batting average?
Divide the number of hits by the number of times the person's been at bat.
Divide the number of hits by the number of times he's been at bat. Isn't that what it said to do?
Yeah.
You said, I can't do that. Why not? Because I was told you can never divide a bigger number into a littler one. Well, someone lied to you. Because you can do that. And the way to do it is with a calculator. Why would I do this myself when I can buy something for $5 that'll do it for me? I mean, if you want to do longhand arithmetic, go ahead.
No.
Yes?
But we
I didn't hear you.
Are you going to count that against us for not showing our work if we use the calculator?
Well, you put down, I used a calculator.
Okay, just making sure.
Okay.
That's what you put down.
Dr. Bodine?
Yes?
I hate to interrupt, but today, because of convocation,
Yeah?
if you can be done in here by about 10:35, because all of the professors are going to be coming in here to get all their gear and stuff.
I thought they were going to the...
Well, excuse me, the professors are going in, the freshman students are going to be gathering in here.
Then we will be done by 9:30, by
All right, let's go.
10:35?
Yes, sir.
We'll be done by then, sir.
Thank you.
Well, then we better not take time to punch in those numbers, because you know how to do it, right?
Yeah.
You understand? Is everybody with me? You punch the numbers in. Only way you can miss that is punch them in backwards.
So what do you punch in first? The 539 and then
Which one do you punch in first?
536.
That would be backwards.
That's what I thought.
Yeah? See, and that's the way to think about it. What I just naturally think is going to be wrong. I do not naturally think good math. I have to go outside of my comfort zone to think good math. And you do it left to right with your calculator. 236, division sign, 539 equals. There you go.
So it's 236 divided by 539.
That's exactly right. That's what they said to do for a batting average in problem 7. Okay, problem 10. In 1914, old Dutch of the Boston Red Sox gave up 25 earned runs. 25 earned runs. Well, if you got them to give up, who cares? Give them up. In 222 and what? 2/3 innings. Find Dutch's ERA. Oh, and then round it to 3 decimal places. So, how do you find ERA? Say, I don't know. Now, you could Google it and say, how do you calculate baseball ERA? But why would you do that when it's right there on the page under problem 9?
Yeah.
What's it say? ERA equals what? 9
ER.
times 9 times what?
ER.
ER divided by IP.
What's the ER and IP?
What's ER?
Earned runs.
Ah, earned runs, the very thing we just put in there. Earned runs. So I put in place of ER what? 25. And what do I put in place of IP? 222 and 2/3. You say, my calculator won't do that. Okay, then hit 2 and divide by 3, and what do you get? You have calculators? Hit 2 and divide by 3, and what do you get? 0.66666. So divide by 222.666. Since they said do it to 3 decimal places. They told us, Gary, to be out of here so the freshmen can come in. We'll be gone at 9:30. 10:30. 10:30. We'll be out of here at 10:30. Okay, everybody follow what to do now? So now we just get our calculator, and what's the first thing you punch in your calculator?
225.
Nope.
9 times 25.
It seems like it'd be. It's like, it just seems right to me. That's why I hate math, because what just seems naturally right to me is wrong. Math is so disgusting. Okay, so it is. Let's just count to 3 and all say math is stupid, and then get on with doing it.
Who's doing the counting?
1, 2, 3.
Math is stupid.
There you go. Doesn't that make you feel better?
Yes.
Now we can do the problem. What do you punch in first?
9
Times. Then hit times. Then hit.
25.
And what do you get for an answer?
225.
What?
225.
Now what do we do with 225?
Divide that.
Hit the divide by button. and put in what?
222.666.
And that'll give you the answer. What'd you get for an answer?
1.010. It's a third.
And that is old Duffy's ERA. And I have no idea what that means, and I don't care. I just work the problem. So you don't have to be a baseball expert. That's not what the rest of you got? Someone got a different answer?
That's what I got.
How many got that answer? Well, majority rules, so the rest of you are wrong. There you go. Okay? Let's move on up here and do another one. Number 12. Isn't this kind of fun? I mean, we might as well have fun. It's disgusting. Estimate how many cups of soup you'll need for the banquet. Soup, cups for the banquet. If what? 1 gallon is 16 cups. Oh, estimate how many cups of soup you'll need, and then if 1 gallon is 16 cups, how many gallons? There's 2 questions here. Well, that's not fair. They put 2 questions in one. Okay, first, let's do the first part. How many cups of soup will you need for the banquet? I don't know. Let's go back down here at the bottom of the page and read about this banquet thing. What are you doing? Oh, it's at the top of the page. You're providing a banquet for how many people?
100.
So what? Does that mean I need 100 cups of soup?
Yes.
Yeah.
Bottom of the page.
Yeah.
According to the bottom of the page formula, each hungry person will consume 1 cup of soup. You follow that? It tells you what the formula is for. So 1 cup of soup for each person. So how many cups of soup do I need? 100. Now, how many gallons of soup do I need? If 1 gallon is 16 cups, 100, watch how I do this. 100 cups would equal what?
6.25.
Now, how would I find that?
You divide 100 by 16.
Does that make sense to everybody, to divide 100 by 16? 16 cups in 1 gallon. Okay, if that doesn't make sense to you, do it this way. 16 cups in 1 gallon, 32 cups in 2 gallons. You with me? 64 cups in 4 gallons. See how we could get 128 cups in 8 gallons.
Okay, I see.
So I kind of know where my answer is going to be. Now I divide 16, take your calculator, 100 divided by 16, and you get what?
6.25.
6 what?
0.25.
6.25. So would you bring to this little banquet 6 gallons of soup or 7?
7.
Yeah, I knew a bunch of ladies are going to say that. My wife always takes more food than we need because she's afraid she'll run out. Probably a good idea. So I'm thinking the answer would be 7. If the answer book says 6, you know what the guy did who wrote the answer book? He never planned a banquet. That's what he did. And he's rounding off to the smallest number. Guys who know math and don't know banquets, going to get themselves in trouble. You always round down, the guy says. That's the rule. Not when you're planning a banquet, it isn't. I wouldn't know that except I'm married to a wife who plans stuff all the time. Number 14. Now, when we're going through here, if you have a question, just raise your hand. But it's best to talk about it right while we're doing it. How many pounds of rice, beans, and so on? Rice, beans, and so on. Pounds. Will you need for the banquet? Well, I got 100 people, right?
Uh-huh.
That told me at the top of the page. Now, rice, beans, and so on. Is that a category down here?
Yes.
Well, wouldn't you know? What is it? What does it say? Each person gets what?
1/3
1/3 of a,
pound.
not a cup, but a pound, right?
Yeah.
So if each person has 1/3 of a pound and I have 100 people, then I take 1/3 of a pound times 100, right? Times 100 people, and what do I get?
33
You go, I can't do that. Okay, take 1 and divide by 3, and what do you get? 0.3333. Take that times 100, and what do you get? 33.33. So what are you going to get? 33 pounds of rice, beans, and so on, or 34?
34.
I would too if I want to be safe. And if you got a bunch of Brazilians coming, you better have more than that. When I was in Brazil visiting some missionaries, we had beans and rice for breakfast, and we have rice and beans for lunch. Guess what we had eating for dinner? Beans and rice again. Just switch the order. And I thought, what's this all about? And you know, after a while I got adjusted to it, and I said, this is kind of a healthy way to eat. Okay, enough of that. Now, you see, if you said 34 and the book said 33, just say I'm right. And someone said, how do you show your work on this? You see how I'm showing my work? What I did with the calculator? And if you did it all with the calculator, just punch the buttons, just say, use the calculator. Use the calculator. But even using a calculator, do you have a calculator that'll take 1/3 of something? I have one at home that does that. They are so cool. It does fractions. Anyone have a calculator that does fractions? Okay, a couple of you do. They are so cool. They just do all that stuff for you. For the rest of you, you'll have to show your work. How I took 1, divide by 3, got 3, and then took that times 100. Number 16. No? Number 18. Now, when I skip them, that doesn't mean you don't have to do them. That means I'm doing kind of one of each kind to show you how it works. But you do all the odd ones for homework. Read the meter, number 18. Read the meter for today. Now, you see the difference between your meter and the meter for problem 17? The meter for problem 17 has little red lines on it. Any idea what those red lines are telling you?
Which direction the dial?
Which direction it's going. I mean, when you look at it, you go put your pencil. Put your pencil on 0, and then which way do you go to get to 1? Left or right?
Left.
Left. So make a little arrow to the left. Then look at the second dial. Put your pencil at 0. Which way do you go to get to 1?
Right.
To the right. Everybody follow that? So draw little arrows on your picture there. Then the next one, and by the way, this will be on the test. A question like this will be on the test, but it'll have the dials with no arrows. So you have to know how to put your arrows on the dials. And so then you look at the next one, and from 0, where do you go to get to 1? See how it works? Now you got your arrows drawn. Now you come down here and read the meter. So you start at 0 and start coming around till you touch the hand. And what's the last number you passed?
5.
Everybody see that? If you just look at the dial and go right down to the dial, you'll get confused. Just start at 0 and work your way around. Okay? Everybody see it? The first one's on 5? Now start at 0 and work around. What's the next one on?
5.
5 again. What's the third one on?
4.
Does everyone see where we're getting these numbers? Put your pencil on 0 and follow the arrow. You go, that is so simplistic. You know, that's the problem. Math is so simplistic and we just don't want to do it. I'm more sophisticated than that. I can just look at it and see the answer. No, you can't. You're going to mess up. You're going to mess up. And by the way, did you know that the key to successful Christian living is looking at what the Bible says and then just doing it? You think about it too long and you're messing up. Just do what it says. It's pretty straightforward.
So I got a question.
Yes?
So the last one would be 0?
Exactly right, because you didn't get to 1 yet.
Right.
Fantastic. That's the way to do it. You say, I don't like that. Well, don't like it. No one said you had to like it. You just write it down. So now that's the first thing. I read the meter. Yesterday, the meter reading was 5501. Now, do I put that number above or below?
Below.
The meter's going up from one day to the next, right? It keeps moving. So I put that number below, 5501. How many kilowatts have been used? So what do? Only 4 operations. Add, subtract, multiply, divide. What do you say?
Subtract.
Subtract. And what's 0 minus 1? You can't do that. Well, you couldn't in grade school, but you can now. You borrow from the 4 and make it a 3, and this becomes a 10, and that makes it 9. And that makes this 3, and this is 0 and 0. So what did you use?
39.
39 kilowatt hours. And I don't know what that means, and I don't care. I just have the answer. But if electricity cost 8 cents a kilowatt hour, 8 cents per kilowatt hour, and I use 39, then what's my electric bill? $0.08 per for 1 kilowatt hour. So what would it be for 39 kilowatt hours?
$3.12.
And you took 8 times 39 on your calculator and got what? What'd you get?
I got 312.
Everybody else get 312? Boy, he doesn't have an all-electric home, does he? I have an all-electric home. $3.12 doesn't pay for anything. If you estimate the same consumption, oh, that's for a day, every day for 30 days, then I take that times what?
365.
Times 30. For the month, they want to know for the month, so I take it times 30, and I get what? $93.60. There you go. We're done with that one. You see how we just walk through this stuff? Just walk through it. Number 20 is another meter reading problem. Do the same thing. 24. 24, a 15-inch humerus bone belonged to a female. How tall was she? How tall is that lady? I have no idea. Wait a minute. What's the formula for a female? Her height equals what?
2.75.
Times h plus what?
28.14.
What's h?
The humerus.
You can't tell that's a 5, can you? H is the humerus bone. And what goes in there?
15.
Everybody see where 15 goes in there? Now I've got numbers. So I take 2.75 times what?
15.
15. And then what do you do with that answer? Add 28.14 and you've got it done. What would the difference in height be if you rounded the measurements in the original formula? Well, if I rounded those measurements, I would have h equals, to the nearest whole number, I would have h equals 3 plus 28, wouldn't I? So put 15 back in there, do the math again, and see how the numbers compare. See how the two answers compare.
So you times 3 and 15?
Yep, 3 times 15. Oh, they didn't put times in there, did they? That's another thing mathematicians do. When they write a number next to a letter, there's 4 operations: add, subtract, multiply, and divide. Which one do they mean? Multiply. Why didn't they put it there? Because they don't need to. Because when there's nothing there, you know it's multiply. Say, I didn't know that. Write it down. Put it in your notes, and you'll be on your way. Okay? Number... No. Okay, there's more of those
So it's 73.
Bone problems.
So 73 would be the answer for 24?
Is 72 the answer?
73.
73 the answer?
Yeah.
Is that what the rest of you got?
Yeah.
73? There you go. Okay, because we're going to run out of time here, let's look at page 25. The others are just using formulas. You're just using formulas and plugging in numbers and doing the math.
I can.
So let's do that next page. What's it say to do? Someone read what it says to do for problem number. Which problem did I say?
You didn't say your problem yet.
I didn't say, huh? Which one do I have circled? 34. What's 34 say to do?
Let's get the difference between the intersection of 90 and 495, the intersection of 90 and 290.
Okay. Take one of these and pass them down. You know what these are? These are rulers. You need a ruler for this problem. So I'm giving you a ruler. Take one and pass them down. Take one and pass them down. You know why this is a ruler? Anyone know what size this card is?
Every 3.
You run out?
Yeah.
You have some extras down here? No? You have some extras up here? Thank you very much. So everybody gets your phone. Everybody gets your phone. Oh, somebody kept one they needed, huh? Somebody wanted 2 rulers. Everybody have a ruler? Everybody got one? Okay, this card. This is what size card is this?
3 by 5.
It's a 3 by 5 card. Okay, so turn this thing sideways like this and look at these. How many little bars are there on there?
12.
Okay, there's 12 spaces. 3 inches have 12 spaces. So 1 inch would be
3. 4.
3 inches is 12. Put it up here.
Yeah. That's
3 inches is 12. So 1 inch would be 4. Divide by 3. Divide by 3. So when you take this thing and count from the top down, 1, 2, 3, 4. There's 1 inch. Put a mark. It's the wrong kind of pen. That won't work on paper. 1, 2, 3, 4. Put a mark. 1, 2, 3, 4. Put a mark. And 1, 2, 3, 4. So now you've got a 3-inch ruler. Right there. Keep it in your book, and you'll always have a ruler with you. And if you're someplace where you don't have one, just ask them if they have a 3 by 5 card. And you can measure anything. Now, what it says to do is estimate the distance between the intersection of 90 and 495. So, where's 90?
It's that big, long.
Oh, okay. 90 is that big long one coming down. See where it intersects 495?
Yeah.
Okay, so put 1 into your card there, and then keep going down to 90 and 290.
So you start in Boston or below Boston.
What?
You start at the 90 below Boston.
Yeah, from Boston, you start coming down 90, but put your ruler at the intersection of 90 and 495. Don't measure from Boston. They want to know the distance from 90 and 495 to 90 and 290. Where's 290?
Farther down.
Further down, close to Worcester or something?
Yeah.
Everybody see it there? So put your ruler on there, and how much is it?
About 3 inches.
2.5 inches.
How many inches?
2.5.
Okay, count the spaces.
Oh.
1, 2, 3, 4, 5, 6. Did you count 6 spaces?
Okay, where are we going?
Down.
Yeah.
From 90 and 490. You see where that is? From that intersection down on down 90 to the intersection where it crosses 290. See where 290 is down there? Take your pencil and put a mark on both of those. You see it? You see where Highway 290 crosses right there where it says Worcester? Put an X on that one where 290 crosses, and an X where 495 crosses. Now put your little card up there and count how many spaces it is. 1, 2, 3, 4, 5, 6. 6 spaces, right?
Yeah.
So how far would that be? 1.5 inches?
Yeah.
And 1.5 inches is how many miles?
15 miles.
Because see, it says up here above this, 1 inch is approximately 15 miles. So if it's 1.5 inches, it would be 15 miles and another 7.5. 22 or 23 miles. And then that's the way you do every one of those. And then when it says, how much does it cost to travel the distance in problem 34? Number 39. That's one of yours, but since we've done this one, let's go ahead and do it. What's it cost to travel? Does it say up there?
The car, 20 miles per gallon, and each gallon costs $1.
Everybody see where you got that information? 20 miles a gallon, and each gallon costs $1.20. So if I went 23 miles, and I get 20 miles to the gallon, I'm going to spend about $1.20 and a little bit more, right? And if I'm estimating, then I'd probably say $1.50. If they want it exactly, then I take 23 divided by 20 and take that times 15. And take that 23 divided by 20 and take that times $1.20. You follow the thinking? Good. And if you follow that, then we're done with that page. Okay, let's do problem 50. Explain in your own words and stop when you get to 48. Stop when you get to 48. Explain in your own words why the reading on the first dial is 9 and not 0. Okay, the first dial, you start at 0 and it stays right there. Agreed? Go to the second dial and it starts going all the way around till it gets past 8, almost to 9. So if the first dial was 0, by the time you went all the way around, wouldn't it almost be to 1? But it's not. That means it was 9 before, and it's almost up to 0. You follow the thinking?
Yeah.
Those of you who said, yeah, you'll get a job to being a meter reader someday, and the rest of you will just have to, I don't know, dig holes for them to bury the line or something. While these guys are out just clicking meters. Okay, we have to get out of here. So I know we didn't work one of those body mass things, but that's, can't believe it. How in the world could they say I need to lose weight? That's disgusting. Okay. Now let's see if I can make this thing go right. Shut this thing off. I guess that's the way I do it. Just shut it off. I'll be in here after chapel to answer questions.